We are on chapter 2.6. We are doing perimeters and areas of similar figures. Now, before we begin, what is perimeter? The distance around a shape, right? Okay, what is area?
The area inside.
Yeah, like how much like surface there would be inside that shape, right? So go ahead and write that down. Perimeters and areas of similar figures. But that's not the page we're going to be on. This is page 76 in case I go too fast, right? I do want you guys to start, though, on page 78. And we're just looking at these two triangles first, okay? Tyrus said, perimeter is the distance around a shape, right? So perimeter would be this side plus this side plus this side, agreed? And you all told me that area was kind of like how much it takes up inside. For example, if this was my backyard, this red triangle, I wanted to find out how much fence I needed. Would I be finding area or perimeter? Good, perimeter, because I fence around the yard, right? If I wanted to find out how much grass or sod that I needed to buy, that's the area. That's how much grass would be inside, right? Okay, first off, that's what we just got to get out of the way, okay? Second thing I want to talk about. What on earth is a ratio?
Something to something.
Something to something. Thank you. There's three ways to write these. Something to something. Can we use words? Can I pick a random number? How about 3 to 2?
3 to 2.
Okay. What's another way to write it?
3 and then a line and then a 2.
Ooh, like a fraction?
Yeah.
Yes. What else?
Dot, dot.
And a colon. Very good. That's 3 different ways to write a ratio. Today you're going to see it in multiple ways. However, the way that we use ratios for mathematical purposes is a fraction. Okay? Sound good? A ratio is comparing two things, right? If I said I wanted to find the ratio of two similar shapes' perimeter, you're comparing one perimeter to the other, right? Or if I said the area, you'd be comparing one to the other. This chapter is super weird, okay? I'm not very good at explaining why it works. I'm just going to tell you how it works, okay? Go ahead and draw these two rectangles to start with. And go ahead and label those one sides they gave you. That's 4, that's 6. The directions say, find the ratio, red to blue, which means red will come first, right?
4 to 6.
Of the perimeters of the similar rectangles.
How do we know the perimeter if they don't give us any numbers?
This is what's super weird about this section, okay? Like I said, I'm not very good at explaining why this is how it works. This is just how it works. Ready? The perimeter ratio, I'm going to say P for perimeter, is side length over side length. So, for example, we're doing red to blue, right?
So it'd be 4/6.
4 over 6. Does that reduce to what?
Yeah.
2/3.
You guys, the ratio of their perimeters is 2/3.
How does that make no sense?
Right? Mind blown. Don't understand it. Don't understand why. But hey, guess what? That's what it is. The ratio of their perimeters is 2/3. Okay? Weird, right? Okay?
I feel like it sounds normal, but no,
Who's
if you
squeaking?
look at it.
You can't do that. I'm recording. Okay, let's do another one. Can you guys draw me these parallelograms on number 4? And you know what you should do in your notes too? Above these two things you've been drawing, I would say, find the ratio of the perimeters. So that way you can go back and be like, oh, that's what we were doing. We were finding the ratio of perimeters. I wasn't just putting numbers on top of numbers for fun. What is the ratio, red to blue, of the perimeter?
11 to 6.
Does that reduce? No. Guys, don't turn it into a mixed number. Leave it. Just a fraction. Don't make it mixed. I know it's improper, but I don't care. Leave it just like that. That's your answer. Easy enough?
Yeah.
Okay. You don't have to write down the next one. We're just going to out loud say it. Okay. I'll wait till everybody gets a chance to finish this. Nope, that's literally it. Weird, right? I know. So weird. How about 5? Red to blue. What's the perimeter?
5/8.
5/8. Good. Let me erase my sheet of paper right there. How about this guy? Red to blue.
7/4.
4/7.
Good, good. Red to blue. 4/7. How about this guy?
No, 14/9.
14/9. Remember, don't reduce it. Don't do anything. That's it. Perimeter equals 14/9.
Read left to right.
Is that super easy?
Yeah.
It really truly is just that easy. Now that's perimeter, right? Let's talk about area. Area is not any different. I guess it is. Little different. When I say that I want to find the area of something and it was like in feet, what does my label look like?
Something feet.
Feet what? Area.
Oh, yeah.
If I said I wanted to find how much carpet to buy for this flooring right here,
Feet squared.
feet squared. Very good. Okay, anytime you're finding area in anything, it's going to be squared, right? Area is squared. We just know that, right? So if I said, what is the ratio of the area of these two shapes? Guess what you do?
4 to 6 feet.
You say 4 to 6, just like before, but then you square all of it. Okay? How do we do that? All you do is pretend that's like distributive property in a way. It's not 4 times 2 though, right? It's 4 squared, 6 squared. Do you guys remember what squareds are?
It's 8 times itself.
It times itself. So what's 4 times 4?
8.
16.
Not plus.
16.
What's 6 times 6?
36.
That's your answer.
So it's just the same thing as
Do you
perimeter but
have
squared.
to
Yep.
reduce if it's
Nope. Leave it just like that.
even if it can be reduced?
Yep. Even because that one can be reduced, right? Because they're even. But no, just leave it just like that. Am I blowing your minds with how weird this is?
Yes.
Because, like, same. So let's review. This one, the area and the perimeter. We found both of them, right? Perimeter equaled 4, 6. Area equaled,
16 over 36.
that's it. That's how your answer would look like. Okay? Want to do another one?
Can we do another perimeter and area one?
Yeah, let's do. Let's go back over here. Remember we just did 11 in your notes? What did you tell me the perimeter was?
It was
11 over 6.
How do I find area?
It's squared.
Square them. What's 11 times 11?
144.
No, that's 12 times 12.
No.
It is a number.
I hate multiplying.
Wait, what did you say it was?
144.
Oh, no. It's 121.
Yeah.
144 is 12 times 12.
Yeah.
What is 6 times 6?
36.
That's it.
Wait.
That's your answer.
So you just
No.
You just square. Square that one, square that one. You're good.
Do you reduce after you
Nope.
do area?
I love it just like this. Okay? Weird. Easy,
Yeah.
but weird.
Kind of easy.
Easy, but weird. Hey, number 5. We did number 5 out loud, didn't we? You guys told me the perimeter was 5 to 8. Area would be 5 times 5 is 8 times 8 is
6 feet
I ate and I ate and I got sick on the floor. 8 times 8 is?
64.
That's your answer. Yes, Grace.
my question is, how does this relate to like
What we're
what
doing?
you're doing about rotations and distortion?
We are going to be using similar figures to talk about dilations next. And how you dilate things is you either grow or shrink, right? Think about your pupils. Your pupils either grow or shrink, right? With light. Okay, that's called a dilated pupil, right?
Yep.
If an object grows, you multiplied it by a whole number. If an object shrank, you multiplied it by a fraction.
That makes sense.
So what we're doing right now is we're finding the fractions that things grow or shrink at which rate, okay? So it's a weird way that it's related because we're not really going to use it for dilations too much. However, they just threw it in there to see if you guys could handle it.
Are we gonna do start on dilations today or
Tomorrow. Yep, yes.
Okay.
Sure. All right, guys, let's keep working. Do you want to just tell me these ones out loud?
Yes.
Okay, you told me perimeter for this one was 4 to 7.
Yes.
Area would be?
20 over.
Nope. I think if anybody makes any mistakes today on today's lesson, it's that you're not squaring correctly. Remember,
16.
4 times 4 is?
16.
Good. 7 times 7 is?
14.
49.
Oh my
Oh.
god.
Not plus. Not plus.
Keep trying to add 'em.
I know. Some kids want to say that's 7 plus 7. Some kids want to say that's 7 times 2. But guys, it's 7 times 7. Yeah. Okay, let's do this one. You told me the perimeter was 14 to 9.
Yes.
That means the area is?
160.
Ooh, 196. Close. 9 times 9 is?
81.
That's it. Not so bad, right? Right? Can we do this? Okay.
You simplify perimeter, but not area.
Meh. They had to simplify it in that example, but after that example, you don't really simplify it ever. Which I don't understand why. Sometimes the book wants you to and sometimes it doesn't, so I'm just going to tell you don't do it for my sake and you'll be fine. Let's go look at some of these. This is when it gets kind of strange, okay? This is where I throw a little wrench into our well-oiled machine. Fun times, right? Look at 10 and 11. It says,
X is.
the figures are similar. Find x. The ratio of the perimeter is 7 to 10. I would like you in your notes to write all of this. I want you to write the directions so that when you look back in your notes, you know what this math is. This math is us finding the ratio of their perimeters, finding x, okay? I'll highlight it again what you're supposed to be writing, this whole section.
Wait, so
The figures are similar, find x. The ratio of the perimeter is 7 to 10. Now, how do I write 7 to 10 as a fraction?
7
Okay, wonderful. I'll wait till you guys write all that down.
could that mean that X could be 7 or 10? Or
Not really. I'll explain it in a second, okay? It is a very weird one. How we found the ratio of perimeters before is we took the side lengths and just compared them in a fraction, right? Right?
mm-hmm.
Well, some people are going to be like, hey, aren't these just side lengths?
Yeah, but what side?
Exactly. We don't care. However, you know what we do care about? Where do you think the 7 came from? The big shape or the little shape?
The little shape.
Okay, why do you think the 7 came from the little shape and the 10 came from the big shape?
Wait, it doesn't matter because isn't the one
The
side
figures
on
are
the-
similar.
Well, here's the thing. I'm not trying to figure out where 7 goes. Like, I'm not trying to figure that out. I just want to know,
Because 10's a bigger number.
10's bigger, so can't I assume that the ratio is small to big?
Yeah.
That's all we're trying to get at right now. You think the ratio is small to big? Yes?
But
Yeah,
what if
probably.
what if it's like one side is really long and the other is really short?
Just kind of like look at the shape. We're not really looking at a specific side right now, okay? So if I'm saying the ratio is small shape to big shape, set that equal to the sides they did give you. Who goes on top? Why are you guys saying x instead of 12?
because it's so small.
Yes, we keep littles with littles and bigs with bigs, right? Now did I set up a proportion that I can solve?
Yes.
Yeah.
How do I solve for x?
Uh,
Cross multiply. 7 times 12 is?
84.
Yeah.
84 equals 10x.
How do I solve for x now?
Divide by 10.
To both sides?
No.
84 divided by 10, you just move the decimal, whoop, 1 in, right? So the answer is x equals?
8.5.
Yep.
Wait, where'd you get a decimal?
Well, see, I know a trick. If you're ever dividing by a 10, how many zeros are in that 10?
1.
Which means you're going to move your decimal up here 1 space to the left.
Oh.
It's just a trick. If this was 840 divided by 10,
Then you move it.
Then you
Then
just
it
take
was-
the,
it'd be 84, right?
well, you just take the 0 off.
Yeah, 84 over 1 is 84. What if this was 761 divided by 10? 760.1? 76.1? Okay, what if I said, oops, that's an eraser. What if I said 832.2 divided by 10?
It would be 83.2.
Good. That was just a little side math lesson in there. But, guys, let's talk about what we did to solve this problem. First, we had the ratio they gave us, correct? Right here. We turned it into a fraction right here. Then we said, I think the 7 represents the small shape and the 10 represents the big shape because 7 is smaller than 10, right? knowing that, we could make a new proportion of small to big, right? And we did that, and we set them equal to one another. Then we cross multiplied, did a little math business, and we found out x equals 8.4. Let's do another one. You guys don't have to draw this one or write this one in your notes if you don't want to. If you just want to stay with me and answer out loud, you can, okay? The ratio of the perimeter is 8 to 5. Who do you think 8 represents? Big shape.
So it'd be big to little.
So how do I set up another proportion to go find x?
8 to 5 is 16 to 16 over
X to 6. X over
16 to
Why does x come
Because
first?
X is on the big shape. And big to little.
Yes. Yes. I'm seeing that it's big shape to little shape, so I also want to keep my next proportion big shape to little shape, right? Now, how do I solve for x? 5 times x is? 8 times 16 is? Wyatt, we need your super mental math.
126.
Oh, you were so close.
Oh,
128. How do I solve for x now?
Divide by 5.
X equals 25.6. Now look at that. Does it make sense for x to be 25.6 and then its corresponding side be 16 on the other shape?
Yes.
I mean, it makes sense, right? Because that one should be bigger than that one. Yeah? Okay, I know those are weird, but that's just how it's just how we do them. Okay, Tyrus?
I vote no one.
Sure. Any questions on those ones? Weird, right? I don't fully understand it either, but that's just how we do it.
Well, what if you like guess wrong?
We're not guessing though.
Well, like you're kind of guessing what number
Goes with what?
What shape?
But we're not though, because I'm telling you, the small number goes with small shape, the big number goes with big shape, okay? And that's how we know to set our next proportion the same way, okay? Okay, any questions on this? You guys feel okay about it? I wish they gave us more like area questions, because I feel like we do a lot of perimeter stuff and not so much a whole lot of area. Let's do number 15 on page 81. Because, you know, usually story problems freak kids out. But you shouldn't, because this is actually pretty easy. The ratio of the side length of square A to the side length of square B is 4 to 9. So hold up, I've got two squares, right?
Yeah.
I've got square A, and I've got square
B.
B. It just told me what the ratio of the side lengths, not perimeter, not area, side lengths.
4 to 9.
Who's going to be 4?
The small one.
Oh, good.
Small goes with small.
For sure.
Small shape to big
So how do
shape.
you know? How do you know where to put those numbers?
Because this is the ratio, right? And it says this is the ratio of side lengths.
Well, I'm talking about like on the shape, like
It's a square.
It doesn't matter because
so
it's
it
a
doesn't
square.
matter.
For
Oh,
sure.
You're right.
So yeah, all sides are the same?
Yeah.
Good question though, Wyatt. The rest of the question says though, the side length, are you listening? Are you listening? The side length of square A is 12. Y'all, didn't you just tell me it was 4? Okay, so they're telling me it is 12. What could the perimeter of square B be? Okay, hold up. What's going on?
It told us it was 4, but then now it's telling us it's 12.
Okay, so it's saying the ratio
They just got itches.
is 4 to 9.
The side length.
The ratio of the side lengths is 4 to 9, right?
Yeah.
But then it's saying the side length of A is 12.
Mm.
What is the side length of B then? Guys, I want to give you a little hint.
Oh, you have to times 9 by 3.
By 3.
What are you noticing?
It's
That there's
divisible.
Uh-huh. Here, guys, look. This ratio they gave you is like somebody reduced the side lengths already, right?
Oh.
Right? They're saying it was 12 over something, but we reduced it. Now it's 4 over 9. What could they have, if we had to unreduce?
Multiply by
Unreduce.
3.
Yeah, multiply both of them by 3. What is 9 times 3? 27? Okay, does that make sense what's going on here?
Yes.
I know.
The reason why they said the ratio was 4 to 9 is because it is 4 to 9 if you reduce it, right?
I thought we weren't supposed to.
Sometimes you do. I don't know. They told us right here that it was also 12. So that's how we knew, okay, this must be a reduction, right? If you're not very good at figuring out the reduction, unreducing type of thing, could you set this up as a proportion? Look at this. 4 to 9 is to 12 to x. Look up here. What's 9 times 12?
108.
Good. 108 equals, what's 4 times x?
4x.
Divide that. Divide that. You get? 27. Woohoo! Now that's what we did doing the unreducing, right? The kids who were like, oh, I can see, you just multiply everything by 3 to get to the next number, right? So what is the side length of b?
27.
Yeah, it's actually 27, right? So let's go put that in there. It's actually 27. I'm going to X these out.
Find the perimeter, so it's
Yes!
27 times 4.
Yes! Very good, because perimeter is 27 plus 27 plus 27 plus 27, or 27 times 4. Let's do that. What do we get?
I'll do it.
27 times 4. 108 what?
108 yards.
Yards. Is it squared?
No.
Why?
Because it's
Because
perimeter.
Very good. It's not area, right? Good. All right, guys. How are you feeling on this section?
It's okay.
Is it okay?
Yeah.
It's weird, but it's okay, right? All right, that was 2.6.